Okay. Hello. It's okay.
Yeah, you might want to go in presentation mode. Yeah, perfect, super.
Okay, thank you. Hello, everyone. I'm honored to give this presentation to introduce Jolywood N-type TOPCon technology. The name of the presentation is the progress of Jolywood 24% plus N-TOPCon technology in mass production. My presentation consists of the following 4 parts. Firstly, I will introduce the PV background and our company brief. The second is the Jolywood N-type TOPCon technology. The second one is some applications of Jolywood N-type bifacial modules in some power plant. The last, I will give outlook and the conclusions. Yeah, firstly, we can it's a Bloomberg's forecast. We can find that the global install capacity will increase from 141 gigawatt to about 170 gigawatt from 2022 to 2020 from 2020 to 2022, and a new increase of about 10%. And the CPIA, the forecast shows that in the next 10 years, the global install capacity will increase from 130 gigawatt to 400 gigawatt, and a new growth rate is about 50%. So in the next 10 years, the PV market will keep fast growing. All of us will have huge opportunities. And why the global install capacity rapidly grows? We can find that the LCoE from the 2010 to 2019, we find that the LCoE dropped from USD about 0.378 per kilowatt hour to now is just 6.8 cents. And in the Middle East, the LCoE is just 1.35 cents per kilowatt hour. So we can find the LCoE dropped about 80% the last 10 years. And in future, I think the LCoE will be drop continually. We can find that the cell efficiency from the last 10 years is 17.5%. Now it's 22.5% for the P-type solar cell. And for the N-type solar cell, we can find the efficiency from 2016 is 21%, and now it's 24% in mass production line. And the module price will be is about in the 2010 the price is 30.5 yuan per watt. Now it's 1.8 yuan per watt. So the price dropped growth rapidly, and the efficiency growing rapidly lead to the LCoE is very competitive with other power generation. In the next now the module price is very low, and in the future it's very difficult to get the cost down. So we find that the efficiency is main the one way to get the cost down continually. We give some calculation. We find that when the cell efficiency increase 1%, and the module cost will be decrease 1.13 cents per watt, and for the BOS cost will be decreased 1.69%. So in the future, when the cell efficiency or module efficiency increase 1%, the total cost reduction will be 2.82 cents per watt. So this is why we hope to get the efficiency to look away to get the cell efficiency, to get the higher efficiency. So in future, high efficiency cell technology route will be in greater development. TOPCon and PERC tandem will be the next generation technology. And this is Jolywood Jolywood Company. Jolywood Taizhou solar technology founded in the 2016, and the registered capital is 355 million. And Jolywood focus on the production of N-type solar cell and modules. Now we have a TOPCon solar cell capacity is 2.1 gigawatt, and the module capacity is about 3 gigawatt. And we also have 150 megawatt IPC solar cell capacity. Now Jolywood is a tier 1 brand of Bloomberg. And this is some patent of Jolywood get from focus on the N-type technology. Now we have 115 patents applied in the N-type technology, and which of 67 patents have granted. Now, why Jolywood choose N-type technology? We can from this picture. We can find that for the high efficiency in mass production, if we want to get the mass production efficiency, you can see the 23%, and in the library, the efficiency, you can see the 25%. All focus on the N-type technology. So this is why Jolywood chose N-type technology. Now we have achieved the TOPCon cell efficiency in our mass production line is about 23.8%, and in R&D, the efficiency have achieved 24.5%. So I think TOPCon technology will be in next 2 years will be developed currently. And this is a theory calculation about a silicon solar cell, the limited efficiency. From this calculation, we can find that for the PERC, the limited efficiency is just 24.5%. So this is why PERC solar cell have huge pressure in the future to improve the efficiency. Now, in the mass production, the PERC efficiency have achieved 23%, and the limited is 24.5. So I think it's a very huge pressure to improve the PERC efficiency. But for the TOPCon, the limited efficiency is 28.7%. Now, in our mass production, the efficiency is just 23.8. So it have a huge space to improve the TOPCon cell efficiency. For the heterojunction solar cell, the limited efficiency is 27.5. So for the silicon solar cell, the TOPCon solar cell has the highest limited efficiency. It's very close to the silicon solar cell limited efficiency, 29.4%. And this is Jolywood N-type roadmap. In the 2016 and 2018, Jolywood focused on the N-PERC solar cell. The LED efficiency is about 22%. From 2019 and to 2025, Jolywood will focus on the N-type TOPCon solar cell, and the cell efficiency will be 23.5 to 25.5 in our mass production. Now we have get the 23.8% efficiency in our mass production, and in R&D, the average efficiency now is 24.1, and the champion efficiency is 24.5. And in the future, we may focus on the tandem solar cell, PERC combine with the TOPCon solar cell, I think this have a huge challenge to get the efficiency exceed 26%. And this is the TOPCon structure and picture of Jolywood. For the TOPCon solar cell, in the front side, we use the P+ emitter, boron diffusion from the P+ emitter, and deposit and LED aluminum oxide and deposit silicon nitride, and then printing slower fingers. And in the rear side, we use 1 nanometer tungsten oxide, and then deposit N+ poly, and then deposit the silicon nitride and printing slower fingers. The cell open voltage now is about 700 millivolts, and for the TOPCon solar cells, it have a high open voltage and low temperature coefficient, and because in the side we use slower fingers, the finger width just 40 micrometer. So the bifaciality now is about 85% for the solar cell. This is the Jolywood N-type bifacial passivation contact technology development progress. We developed a TOPCon solar cell from 2017, and now in that time the efficiency just 21.8%, and after 3 years development, now we have achieved 24.5 efficiency in R&D. This is the pilot line in R&D. We can get the average efficiency is about 24.09%. This is the R&D pilot line.
Dr. Liu, you just muted yourself.
Okay. Is it okay?
Yeah. Please start with this slide again. So I think it's just happened when you move to this slide.
Okay. This is the show how to we get 25% efficiency. This some include the P+ emitter. We use selective P+ emitter, LC coating optimization, and some electrode optimization, and especially in the poly optimization, use ultra thin N+ poly and so on, and also including local P+ poly. We can hope you can get the efficiency exceed 25%. Okay, this is the in the last month we have announced our POPAID technology. We announced the J-TOPCon, the second generation J-TOPCon technology, POPAID TOPCon technology, and in before Jolywood TOPCon, the first generation TOPCon technology is based on the LPCVD2 and ion implantation, and the process about 12 steps, and so the cost is much higher than PERC. Now we developed a new equipment we named POPAID. This equipment can reduce the progress step from 12 to 9 steps. It's almost the same as the PERC, and the cost will be go down rapidly. the first generation TOPCon technology is based on the LPCVD. Based on LPCVD, there are two ways. One is use ion implantation to form the unplugged poly, and the other is use phosphor diffusion to form the unplugged poly. And the two ways have whipping plating, because LPCV2 will get the unplugged poly from the rear side wrap to the front side. We use extra chemical cleaning process to remove the welding plating unplugged poly. So the cost will be high, and the process steps will be and the process will be 12 about 3 another 2 cleaning steps to remove the wrapping unplugged poly. For the second generation TOPCon technology, we base on the single side in situ doping deposition. We use POPAID. POPAID is plasma oxidation and plasma assist in situ doping deposition. And by this way, the unplugged poly can directly deposit on the wafer surface, and no welding plating. And the tungsten oxide is also by POPAID to form the 1 nanometer tungsten oxide, and then deposit unplugged poly. And then anneal to form the unplugged poly, the real side field. And we measure the J naught of the real side formed by the POPAID technology, and the J naught is just 3.5 femto amplitude. It's very low, and it's lower than formed by LPCVD and PECVD too. And this is a comparison between TOPCon solar cell and P-type PERC solar cell. And for the first generation TOPCon solar cells, the VOC is just 700 millivolt, the efficiency 23.5, but reality. And it's very important for the N-type TOPCon solar cells is 0 LID and the very low LeTID. The data shows that for the N-type TOPCon solar cells, the LeTID is less 1%. And for the second generation TOPCon technology, we think we can show the efficiency exceed 24.5% in the next year in the mass production line. And this is TOPCon modules based on the 182 millimeter silicon wafers, and based on the TOPCon solar cell high efficiency, we can choose the module power for the 72 solar cell. The module power will be 570, and for the 78 modules, the module power will be 650. And for the NEWA black, for the left one is the NEWA black. This total black modules is focused on the residential market, and in the right is the NEWA super with it have a very high module power. It focused on the power farm, solar farm, and it have a very lower LCoE. And this is the TOPCon value advantage compared with the PERC. This is just a simple calculation. For the PERC modules, the module power about 540 for the 182 silicon solar cell. For the TOPCon, the module power will be 555, 560, and 570. And this some parameters such as bifaciality, temperature coefficient, and degradation is from the datasheet. And we calculate the LCoE. Now we assume the same LCoE is 0.136 yuan per kilowatt hour. And in this LCoE, the module price of PERC is 1.5 yuan per watt. And if we get the same LCoE, we can find that the TOPCon modules, the price should be 1.68. If module power is 570, the module price should be 1.75 yuan per watt. This means that TOPCon modules have about 0.25 yuan per watt additional price, additional value gain. And for the TOPCon solar cells and modules, the gap between the PERC and the cost gap between the PERC and the TOPCon is less than 1 cent. So, and the cost is less than 1 cent, but the value is 3 cent. So we think the TOPCon is most competitive in the solar farm in the lowest LCoE. Yeah, this is the TOPCon value advantage. BOS cost will be reduced 3.9%, and the LE and the LCoE will be decreased 6.6%, and RE will be wrapped 3.9%. And next is about the LeTID. Firstly, we can find for the PERC, no matter multi or mono, we have a huge LeTID risk. And TOV node has also published some data about the LeTID test. They find that for the PERC modules, the LeTID is about 2 or 3%. For the N-type port, for the N-port modules, the LeTID is near 0. And for the TOPCon N-type TOPCon modules, after the LeTID test, we can find the module power have some increase about 1%. So according to this data, we can find that for the N-type, no matter N-port or TOPCon, the LeTID is very lower than PERC. And this is some data from our Jolywood lab. We can find that the LeTID is also less than 1%, just 0.5% after the LeTID test. Why N-type cells and modules have the lower LeTID? There are some publications have studied this phenomenon. The conclusion is that the hydrogen in the N-type and the P-type wafer is totally different. The first is the solubility of hydrogen in N-type wafers to be significantly lower than in P-type. The less hydrogen would in diffusion to the N-type silicon than P-type silicon during firing. The less hydrogen means the less hydrogen phosphor copper and the less hydrogen precursor, and the less hydrogen X and the less generation. So for the N-type no matter unpaired and TOPCon solar cells, in theoretically, it have a lower LeTID, and the data also show that the TOPCon solar modules have the LeTID is less than 1%. And these some applications of N-type modules. The first is the Panda power plant. In this project, Jolywood supply about 30 megawatt N-type bifacial modules, and some top runner project such as Sihong fishing farming project, and Oman project. This is in the Middle East. The capacity is 125 megawatt, and some solar farm in Netherlands and some European. And this is the Middle East project, 150 megawatt, and the modules 100% supplied by Jolywood. And this summary about the shipment of the N-type bifacial modules. Now we have shipment exceed 2 gigawatt N-type modules in all over the world. And in this year, we supply Oman Ibri 2 projects. The capacity is 458 megawatt, and the other is the Diwa 4 project from Aqua. The capacity is 320 megawatt. So we can find that in Middle East, Jolywood N-type bifacial modules is very competitive. This is because in the Middle East, the high temperature and the high adobe of the background, and this region is can get the N-type bifacial modules have the more power generation, and so in these regions use N-type bifacial modules, we can get the lowest LCoE. This is why in the Middle East, Aqua, Mazar, and Matribua to use the N-type bifacial modules in the Middle East. Okay, this is a conclusion. Jolywood focus on the production of N-type solar cells and the modules, and now we have 2.1 gigawatt TOPCon cell capacity and 3 gigawatt module capacity. And in our mass production line, we can achieve the energy efficiency about 23.5% per 23.85% in our mass production. And in our R&D power line, we can achieve the efficiency at about 24.09%, and the champion efficiency is 24.5%. And the roadmap of industrial bifacial passivation contact solar cell will exceeding 25% in the next 2 years. And the N-type TOPCon bifacial modules shows no LeTID, no LID, and very low LeTID. And Jolywood bifacial modules have been widely applied in the large amount of PV system all over the world. The data show how that the bifacial modules at least 10% power gain from a bifacial design comparing with the monofacial power plant. Okay, thank you.
Thank you, Liu, for this great presentations, and actually also thank you for spontaneously taking over now, because I mixed up actually the order and taking you first before Rena, which will come afterwards. Maybe we have time for 2 questions. There were a lot of questions. I think we will address most of them later on in the panel discussion, so that we don't delay here too much, but maybe we take 2 first. One, I think, was regarding something on reliability also, because of course Jolywood is not only a pioneering TOPCon cell module manufacturer, but you also are one of the world leading backsheet manufacturers. So, and you referred to one nano alloy backsheet in the new product, actually. Can you just explain what that is? That was a question.
他说就是产品的这个组件，就是说我们不光是在做组件，也还是在做背板，所以说通过这两个结合，你说，就通过这两个结合的话，就说我们的这个产品能不能有更好的一个这个可靠性
？Yes, for Jolywood, in the 2008, Jolywood focused on the backsheet, and from 2016, Jolywood focus on the N-type bifacial solar cell and modules. Yes, in future, we want to develop the bifacial modules use a transparent backsheet. You know, for the transparent backsheet, now we have give a 30 years warranty for our transparent backsheet, and for the bifacial modules use transparent backsheet, the weight is much much lighter than the double glass bifacial modules. But now in some special regions such as Middle East and some other the lake project, they want to use a double glass. They worry about the stream to damage the modules. So in future, we for our transparent backsheet will be resolve this problem to develop the special backsheet to prevent the stream and get the module reliability is much better than double glass. And now in the European market, our customer is very likely to use bifacial modules, use a transparent backsheet due to the weight. The weight is about 30% lower than the double glass. Okay.
Okay, and then one more quick question before we come to the next presentation. So at the moment, we all know there's some shortage on module supply, and you showed really very interesting and high efficiency modules. What's your availability now at the moment for modules, and when, and especially also these new modules that you showed, the high efficiency, the 500 watt plus modules? When will they hit the market?
现在的供应会怎么样
Okay.
比如说我们供应我们现在还是可以接受更多的订单的。
Now for the Jolywood 什么东西？
我们刚才介绍了我们高功。
Okay. Now, due to the glass price is very high now, lead to the module capacity is lower than the supply, than the market demand, and lead to the module price go rapidly. In the next year, I think the market will be developed, will be need high module power modules, and Jolywood focus on the high module and focus on the N-type modules with a high module power, and our customer is think our module is competitive than the some other competitors of the P-type modules.
Okay. Okay. Perfect. Yeah. Then let's continue then in the panel discussion, and then thanks for the moment for your contribution. So let's continue now with the presentation of Rena. I'm really I'm really happy to have with us Dr. Holger Kühnlein. Almost all his working life, Holger has been working with RENA, a global leader